Memory feels effortless. You experience something, you remember it, but inside the brain, memory is not simple at all. Every memory must travel through a complex biological process before it becomes stable. Sleep is one of the most important parts of that process. Without sleep, memory begins to weaken. To understand why, we first need to understand how memories form. When you experience something new, the information is first stored in a small structure deep inside the brain called the hippocampus. The hippocampus acts like a temporary storage system that it records events from the day and holds them for a short period of time. But the hippocampus cannot store memories forever. It has limited capacity. For memories to become long-lasting, they must move to other regions of the brain, particularly the cerebral cortex. This transfer does not happen while you are awake. It happens during sleep. During sleep, the brain begins replaying experiences from the day. Neural patterns that were active during waking hours become active again. Scientists call this process memory reactivation. The hippocampus communicates with the cortex, gradually strengthening neural connections. With each replay, the memory becomes more stable. Over time, the memory moves from temporary storage into long-term networks. But when sleep is restricted, this process becomes disrupted. Memories remain stuck in temporary storage. They are not fully consolidated. As a result, they become easier to forget. One of the most important stages for memory consolidation is deep sleep. Deep sleep produces slow brain waves called delta waves. During these slow waves, large groups of neurons synchronize their activity. This synchronization allows different brain regions to communicate efficiently. It creates the perfect environment for transferring memories from the hippocampus to long-term storage. If deep sleep is shortened, memory consolidation becomes weaker. The brain still attempts to store information, but the process becomes less reliable. Another stage of sleep plays a different role in memory. REM. Sleep supports associative learning. During REM sleep, the brain connects ideas that were previously unrelated. Information from different experiences becomes integrated. This is why creative insights often appear after sleep. REM sleep helps the brain reorganize knowledge. When REM sleep is reduced, the brain becomes less flexible in how it connects information. Learning becomes more rigid. Problem solving becomes harder. Sleep deprivation affects memory even before sleep begins. When the brain is tired, the hippocampus becomes less active. This means new memories are not encoded as efficiently. That information may pass through the brain without being properly recorded in laboratory experiments. Participants who are sleep deprived show significantly weaker hippocampal activity when learning new material. Their brains struggle to create new memory traces. In other words, sleep deprivation damages memory in two ways. First, it reduces the brain's ability to record new information. Second, it disrupts the process that stabilizes memories during sleep. Both stages of memory formation become impaired. Sleep deprivation also affects working memory. Working memory is the system that allows you to hold information in mind temporarily while performing tasks. For example, remembering a phone number long enough to dial it. Or keeping track of steps in a complex task. Working memory depends heavily on the prefrontal cortex. This region of the brain is extremely sensitive to sleep loss. When sleep is restricted, prefrontal activity decreases. As a result, working memory capacity declines. You may forget what you were about to say, may lose track of a conversation. You may struggle to follow complex instructions. These small lapses are signs that the brain's temporary storage system is under strain. Sleep deprivation also affects emotional memory. Normally, sleep helps reduce the emotional intensity of experiences. An event may still be remembered clearly, but its emotional charge decreases. This helps the brain maintain emotional balance. Without sufficient sleep, emotional memories remain stronger. Negative experiences feel more vivid. Worry persists longer. The brain becomes more sensitive to perceived threats. This can contribute to anxiety and stress. Another surprising effect of sleep deprivation is false memory formation. When the brain is tired, it becomes more likely to confuse similar memories. Events may be remembered inaccurately. Details may become distorted. In some cases, the brain may even remember events that never occurred. This happens because the brain relies on pattern recognition to reconstruct memories. When sleep is restricted, this reconstruction process becomes less precise. Errors become more common. Sleep deprivation also slows the speed at which memories can be retrieved. Even when information has been stored successfully, accessing it becomes more difficult. You may know that you know something, but the answer feels just out of reach. This is often described as mental fog, that the information exists in the brain, but the retrieval process is slower. Sleep also protects memory through another important mechanism. During deep sleep, the brain reduces the strength of less important neural connections. This process is called synaptic DOWNSCALING. Throughout the day, experiences strengthen many connections between neurons. If these connections continued strengthening indefinitely, the brain would become overloaded. Sleep selectively weakens unnecessary connections while preserving important ones. This keeps memory networks efficient. Without sleep, this reset process becomes incomplete. The brain becomes cluttered with excess neural activity. Focus becomes harder. Important memories compete with irrelevant information, but the encouraging news is that memory systems can recover. When adequate sleep returns, memory consolidation improves again. The hippocampus becomes more active. Neural replay resumes. Learning becomes easier. This recovery may take time, especially if sleep deprivation has been prolonged, but the brain is remarkably resilient. Given the opportunity to rest, it rebuilds its memory systems. Sleep reminds us that memory is not created in a single moment, it is built slowly, experience by experience, night by night. And every night the brain expects the same thing: time to reorganize the information of the day. Time to strengthen what matters, time to forget what does not. When sleep arrives, the brain begins this work quietly, carefully, transforming experience into memory. And without that work, memory slowly begins to fade. Another important way sleep protects memory involves how the brain prioritizes information. During the day, the brain encounters an enormous amount of sensory input. Faces, conversations, images, sounds, facts, ideas. Not all of this information is equally important. If the brain attempted to store every detail permanently, memory would quickly become overwhelmed. Sleep helps solve this problem. During sleep, the brain evaluates which experiences are meaningful enough to keep. Signals related to learning, emotional importance, or repetition are strengthened. Other signals gradually weaken. This process allows memory systems to remain efficient. Without sleep, this prioritization becomes less precise. Important information may not receive the reinforcement it needs. At the same time, irrelevant information may remain active longer than it should. The brain becomes crowded with unfinished processing. This can produce the familiar feeling of mental clutter. Thoughts feel disorganized. Ideas feel harder to connect. Attention drifts more easily. Another layer of memory processing occurs in communication between different brain regions. The hippocampus does not work alone. It constantly exchanges signals with the cortex, the thalamus, and several other neural structures. During sleep, these networks synchronize their activity through rhythmic patterns known as sleep spindles. Sleep spindles are brief bursts of electrical activity that occur during certain stages of sleep. Researchers believe these bursts help transfer memories from short-term storage into long-term networks. When sleep is restricted, the number and stability of sleep spindles may decrease. This weakens the communication between memory systems. Information that might have become a stable memory instead fades. Sleep deprivation can also affect spatial memory. Spatial memory allows the brain to remember locations and navigate environments. This ability depends strongly on the hippocampus. When sleep is shortened, hippocampal activity becomes less efficient. People may find it harder to remember where they placed objects. They may forget directions more easily. Even familiar environments may feel slightly less intuitive. Another subtle effect appears in procedural memory. Procedural memory involves learning skills rather than facts. Typing on a keyboard. Playing a musical instrument, performing complex motor tasks. These skills improve through practice, but sleep plays an important role in stabilizing them. After learning a new skill, sleep helps refine the neural pathways that control movement. Without sleep, this refinement becomes weaker. Progress slows, errors remain more frequent. the brain continues practicing the skill, but improvement occurs more gradually. Perhaps the most remarkable feature of memory is its adaptability. Even after periods of sleep deprivation, the brain can recover much of its memory capacity. Once regular sleep returns, neural replay resumes, sleep spindles, stabilized dot connections strengthen again. Over several nights of consistent rest, memory systems gradually return to normal function. This resilience reminds us that memory is not a fixed structure. It is a dynamic process. It grows, and repairs itself continuously, but it depends on one condition: sleep. Because sleep is the moment when the brain pauses its interaction with the outside world and turns its attention inward.